Bismillahirrahmanirrahim. This is unit number 15, Electromagnetism. And this is exercise for MCQs, Physics 10, National Book Foundation. The first MCQ, question number 1. If magnetic field of a conductor passing perpendicularly through cardboard is anticlockwise, then the direction of current in it due to free electrons is. Now, here there are few things to note, that we need to find the direction of current in a magnetic field which is passing through a cardboard. Now, if any conductor, when there is a current I passing through it, it develops a magnetic field around it. Now, how do we find the direction of the magnetic field? That is the right hand grip rule or the left hand grip rule. Which one to use where? That only depends upon the kind of current we are dealing with. If it is conventional current, we use the right hand grip rule, and if it is the current due to free electrons, then we use the left hand grip rule. Kindly note that if it is conventional current, use the right hand grip rule, and if it is the current due to free electrons, then it is left hand grip rule. So here in this case, since we are dealing with current due to free electrons, then we will be using the left hand grip rule. So this is my left hand, and I make a grip over the conductor. If my thumb points in the direction of electron current, then my curl of the finger shows the direction of magnetic field, which in this case, you see, it is my left hand, the curl of the finger is in clockwise direction. Now, here I have made a cardboard here. Consider it as a cardboard, but I have written numbers like 12, 3, 6, just to show you what is the clockwise direction. This is, the needles will move from 12 to 3 to 6 and then back. If this is the conductor passing through the cardboard and I use my left hand grip rule, my thumb points in the direction of the conductor, the curl of the finger is clockwise direction, right? Now, the question says that the magnetic field conductor passing perpendicular to the cardboard is anti-clockwise. The magnetic field is anti-clockwise. So I must now see how anti-clockwise works. So if I use again the same my left hand, but I have to arrange my curl of the finger such that it is anti-clockwise. Now here in this case, the curl of the finger shows the anti-clockwise direction. This is the direction of the magnetic field. Thumb points in the direction of the current. So in this case, it is into the cardboard. The current is into the cardboard. Out of the given choices, my second B choice is the correct answer. The direction of current is into the cardboard. Question 2. According to right hand palm rule, fingers indicate. The right hand palm rule is used to know the direction of the force on a current carrying conductor in a magnetic field. Now let's say this is the conductor. The current I is passing in this direction. This is the magnetic field which is perpendicular to the conductor. And according to the right hand palm rule, stretch your fingers and thumb such that the thumb becomes perpendicular to the fingers. Then if the fingers, like this is the palm, my thumb is stretched, it becomes perpendicular to the fingers. The thumb becomes perpendicular to the finger. Then if the fingers point in the direction of the magnetic field, my fingers point in the direction of the magnetic field, and conventional current is in the direction of thumb, then force is directed out of the palm. This is the force which is acting out of the form. Now kindly note, I have said the conventional current here. I am using the right hand palm rule which is used for the conventional current, and if it is current due to electrons like in the previous question, I use the left hand palm rule. So here, since it is not written, the direction of the current is not given, we always use the conventional current unless it is given that it is electronic current. Now the right hand palm rule is used for the flow of conventional current, and for electronic current the rule is applied the same way but with the left hand. So may it be right hand or left hand rule, the fingers always point in the direction of the magnetic field. So the question is, according to the right hand palm rule, fingers always indicate the direction of magnetic field. So the correct answer here would be D, magnetic field. Now this is question 3A. Please note that in your book there are two questions numbered as 3. I am writing the first number 3 question as 3A and the second number 3 question as 3B, not changing the remaining numbers in the exercise. So this is the first question number 3, 3A. A conductor is placed horizontally. Direction of current in it is east. Magnetic field is out of page. Perpendicular to the conductor, what is the direction of force on the conductor? Now, once it comes to the direction of north, south, east and west, remember north is always upward, south is down, east point to the right and west to the left. So there is a conductor which is lying horizontally, direction of current is to the east. There is a magnetic field which is perpendicular to the conductor and it is out of page. This circle with a dot in it shows the magnetic field out of page. Now, in order to find the direction of force on this conductor, use the right hand palm rule. Now, if you stretch your right hand palm such that the thumb becomes perpendicular to the fingers, point your thumb in the direction of current and fingers in the direction of the magnetic field, that is out of the page. The palm will direct the direction of force. Since palm is downward here, the direction of force is also downward in this case, which is the south direction. So the direction of force is toward south. So out of the given options, option C is the correct answer, south. Now this is question number 3B. The third question. Direction of magnetic field inside permanent bar magnet is. Now as you can see a bar magnet, the direction of the magnetic field is always points out in the north, on the north pole, and it goes in on the south pole. This is outside the bar magnet. But once it goes inside the bar magnet, the magnetic field always direct from south to north in order to maintain the line pattern. If there is any other pattern, this line pattern will not be maintained and it may not remain a magnet. So for this bar to remain as a magnet and to show the south and north pole inside the bar, it will be from south to north. Question number 4. Which of the following parts is responsible for DC motor coil to rotate in one direction? Now, the given answers are load, slip rings, commutators and battery. Battery is not part of the motor, a DC motor. Load is also not part of the DC motor. These two answers are just out. Only B and C, the slip rings and commutators. Now, know that in a DC motor, commutator is a set of copper connections attached to the ends of each of the coil of the armature. The purpose of the commutator arrangement is to ensure that during every half cycle of the rotation of the coil, the direction of the current remains same in each segment so that same direction of torque is achieved to run the motor in one direction. So it is the commutator which are responsible for the motor to rotate in one direction. The correct answer is commutators. Question 5. If a coil moves parallel to a uniform magnetic field, the induced EMF will be. Now recall that EMF in a coil is induced due to magnetic field when there is a change of magnetic flux through the coil. Now what is magnetic flux? Magnetic flux is number of lines of magnetic field passing through an area, a loop, coil or a region is called magnetic flux. More lines, greater magnetic flux. Less lines, smaller magnetic flux. So when a coil passes a magnetic field perpendicularly, there would definitely be change in the lines of magnetic field through the coil. But if the coil moves along the magnetic field or say parallel to the magnetic field, there will be no change in the magnetic flux. So no change in the magnetic flux or no change in number of lines of the magnetic field, no EMF. So in this case, the answer will be 0. Question 6. The device which converts mechanical energy to electrical energy is. Now again see, the devices name are given as motor, generator, thermocouple and battery. Know that battery has no mechanical part in it. A thermocouple again is a static device. It has no mechanical part in it, no motion. These are the two things, motor and generator. A motor is something which receives electrical energy as input and converts it into mechanical energy. And whereas generator is the device which converts mechanical energy, we provide mechanical energy to the generator, a rotation, and that rotation converts it into electrical energy. So generator is the device that converts mechanical energy to electrical energy. Correct answer here is B. Question 7. Step-up transformer increases what? Transformer is the device that increases or decreases the AC voltage or AC current. A step-up transformer increases AC voltage but decreases the AC current. So correct answer here would be voltage. Step-up transformer increases voltage. It is the AC voltage. Question 8. What is output of step-up transformer having turn ratio 1:50 if 50 volt DC is applied at its primary coil? Note that the transformer is a device that increases or decreases the AC voltage or AC current. It is increasing AC voltage, alternating current, because there is a change in the direction of the current here, and that change in the direction of the current induces a EMF in the coil attached to it, and that coil again due to mutual induction develops an EMF in the other secondary coil. If there is no change like in AC voltage, change in the direction of the current, there would be no change in the flux, so no current will be produced. Since DC is a static voltage, the input of 50 volt DC would make no effect. It is direct current, there is no change. Once DC is applied, it starts at certain level like 50 volt. Throughout every smallest part of the time it would give 50 volt, no change in the current or no change in the EMF. So a 50 volt DC applied at primary coil would result a 0 output. So the output here is C, 0. Question 9. If magnet is moved toward the coil with uniform acceleration, magnitude of the induced EMF in the coil will. When magnet moves toward the coil with acceleration, it means that speed is increasing. This also means that the number of magnetic field lines is increasing through the coil. Hence, it increases the EMF. The correct answer here is A, increases. Question 10. A transformer has 100 turns in the primary and 500 turns in the secondary. If 6 volt is applied across its primary, the voltage induced across its secondary would be. So the formula given for the transformer voltage to number of turns is Vs over Vp is equal to Ns over Np. It can also be written as Np over Ns, Vp over Vs. We can switch the denominator with the numerator and on both the sides, or we can also say it is Ns over Np is equal to Vs over Vp. We are just changing the sides here. This we usually do in order to see what we need to find. Like in this case, we need to find the voltage induced across secondary. So voltage across secondary is Vs. So I use this formula here, Vs on top, Vp and the denominator, and according to Vs over Vp, we write Ns over Np. Filling in the quantities given, we write 500 turns in secondary, 100 turn in the primary, 6 volt in the primary, and this once solving this, these two zeros go with these 2 0. This remains 5 over 1, moving the 6 to the right side as multiplier, and Vs becomes 30 volt. So the correct answer would be 30 volt.